Okay, we're going to look at testing for gases. This comes into the chemical analysis topic, it's 8.2 in the AQA specification. So just briefly gives the test you need. Test for hydrogen gas, so that ignites with a squeaky pop. Testing for oxygen, that will relight a glowing splint. Chlorine, you test for that, it will bleach damp litmus paper. In other words, it will take the color away from it. And carbon dioxide, that it will turn lime water cloudy. So that's the basics. You're the only what you need to know for this topic. But what I'll do is I'll go through how you can make each of those gases and where they come across. You'll come across them in the rest of the specification, just to give a bit of context to it. So okay, let's start off with hydrogen then. So what we've got in here, so this would be a reactive metal such as magnesium, or it could be zinc. Magnesium would be quicker. And if you put that into an acid, let's say hydrochloric acid, dilute acid, you will you'll get hydrogen bubbles, okay, and you'll collect the hydrogen there, and then you can test the hydrogen, collecting the hydrogen over water. The water level will be pushed down as the hydrogen, and we get more and more hydrogen here. So the equation for that is so magnesium plus hydrochloric acid will go to magnesium chloride. Now magnesium chloride has got the formula MgCl2 because magnesium is group 2, so it forms a 2+ ion. Chlorine is group 7, so it forms a 1- ion, and you'll get hydrogen gas. Okay, so to balance that, we just need to put a 2 in front of the HCl. Okay, so that's you come across that in the acids topic, and also in the metals topic, where reactive metals will react with acids to produce hydrogen. In fact, most metals, except the really unreactive ones like copper and silver, will all react to produce hydrogen gas. And a salt. This is a salt. Of course, a salt is when you replace the hydrogen atoms in an acid with metal atoms. Right, let's talk about testing for oxygen then. Right, so here you can see relighting a glowing splint. So in that beaker there, we have got a solution of hydrogen peroxide, H2O2, in aqueous solution. Now hydrogen peroxide decomposes very slowly. According to the following equation, it will give you water and oxygen. Now, in order to balance that, I need to got too many oxygens on the right hand side, so I need to put a 2 there. That means I put a 2 in front of the water, and then it's all balanced. And so you can store hydrogen peroxide for years and it won't go off, because it's a very slow reaction. But you can speed it up by adding a catalyst, and that's that black powder there, which is manganese dioxide. That's a catalyst, and it's such an efficient catalyst that immediately it starts bubbling. So these are little bubbles of oxygen we got here. So you just let the oxygen build up on the beaker there for a few seconds, and get you a glowing splint here, and you lower that down into the beaker, and it will relight. Of course, the reason why it relights is because in order for things to burn, they need oxygen. There's 20% oxygen in the air, so like here you're going to have 100% oxygen, so it will burn even much better than normal. So it will actually burst into flames if it's just glowing. Okay, so that's the test for hydrogen for oxygen. Right, now the next one here, we're testing for carbon dioxide. So what you might have used this in the rates of reaction part of the topic, because it's quite an easy one to measure the speed of this reaction. So what I've got in here is I've got some calcium carbonate, and this is in hydrochloric acid. An acid and a carbonate is going to give you carbon dioxide, and it will give you a salt and water. So if we look at that one, we've got calcium carbonate plus HCl, solid, It's going to give us CO2. And it's going to give us the salt, and the salt is going to be calcium chloride. And now, like we said, the magnesium chloride, it's because it's CaCl2. Calcium is in group 2 of the periodic table, forms a 2+ ion. That's in aqueous solution. And you'll also get H2O made there. If you want to balance that, we've got 2 chlorines on that side of the equation, so we're going to need 2 HCl, and you'll see that that's balanced. So you use that rates of reaction experiment. You can measure the rate by the volume of carbon dioxide made, or you can do it by mass loss, because this tube is going to get lighter as time goes on because you're losing CO2 from it. Right. In there we've got lime water, and I won't talk about lime water is actually calcium hydroxide. I won't talk about the reaction going in there because it's not on the specification, but that forms a solid and it will go cloudy, and that's a positive test for carbon dioxide. Okay, the last one is chlorine. Now you come across that in the electrolysis topic. So what I've got here is I've got sodium chloride solution, and we're going to electrolyze it. And now at the negative electrode here, you're going to get hydrogen gas. We're not really interested in that. Okay, not testing for that. And at the positive electrode, you get chlorine produced. And if you hold a piece of pink litmus paper, or you can use blue litmus paper, and you hold it to the litmus paper, it will lose its color and go white. Now that was one of the required practicals in the electrolysis topic. You know, you're testing a load of what products you get at each electrode when you electrolyze different solutions, and I think you do sodium chloride. You can also do copper chloride as well. That's and you'll get chlorine gas given off there. I'll just write down the equation there. So overall what happens is you get NaCl, aqueous, and water. The water actually gets broken up in this because you get, because sodium is a pretty reactive metal, you get hydrogen at the negative electrode. You don't get the metal, you don't get sodium. Sodium chloride and water, you're going to get H2 gas, that's made at the negative electrode. You get chlorine gas at the positive electrode, and what will be left in solution here, this is sodium hydroxide, so that will become, it will make it quite alkaline to NaOH aqueous solution. Okay, that equation is not balanced, so I need to put a 2 there, don't I? 2 in front of the water. All right, it's balanced now. Okay, so that's how you test for the gases, and just a little bit of context, talking about the rest of the specification really.